Hi, I'm Balaji Seshadri, Product Marketing Manager at Microchip Technology. In this video, I'd like to show you how easy it is to get started with the latest dual-core dsPIC33CH digital signal controllers using our MPLAB Code Configurator or MCC. The dsPIC33CH DSCs feature a master core and a slave core, each with their own dedicated memory and peripherals. Using the slave core, you can implement time-critical control functions while the master core is busy running the user interface, system monitoring, and communication functions. MCC reduces the time required to configure the two independent cores and helps avoid any resource allocation conflicts with ease. Before we start, please make sure you have the latest MPLAB X IDE, XC16 compiler, and MCC plugins installed. For today's demo, we will use the Explorer 1632 development board with a dsPIC33CH 128 MP508 general purpose plugin module. Now, let's look at our 4 simple steps to get this demo ready. First, let's set up the master project. Then, export the slave configuration settings from the master project. Now, configure the slave project and import the configuration settings. And finally, include the slave image in the master project. In this demo, the master and slave cores are configured to exchange data using the master-slave interface or MSI in an event-based mode that lights up the respective LEDs on the board to indicate a successful exchange. Now, let me walk you through a live demonstration on how you can configure your dual-core project using MCC. Create a new standalone MPLAB X project for the master. Select the device on your board, in this case a dsPIC33CH 128 MP508 device. Select your debugger/programmer and choose the latest version of the XC16 compiler and then save the project. Now, launch MCC and save the configuration file. Under Device Resources, navigate to Peripherals, then Slave Core and double-click on Slave 1 and give the project a name. Next, set up the master-slave interface by enabling Protocol A for communication from master to slave and Protocol B for communication from slave to master. In the Pin Manager grid, select pin RE0 as a GPIO output for the master core and assign ownership of pin RE1 to slave 1. Under the Project Resources tab, double-click on the pin module to verify the pin configurations. You may now assign a custom name like LED Master to pin RE0. Now, save the master configuration settings. This creates a configuration file in the master project folder that will be imported into the slave project later. At this point, make sure to check the Notifications tab for any warnings, and if there are any, we recommend that you resolve them before proceeding further. Click the Generate button now and a pop-up window should appear asking for confirmation. Click Yes to continue. Now that we have completed the master setup, let us now move to the slave configuration. Create a separate standalone MPLAB X project for the slave core by repeating the same steps used for creating the master project. Ensure that you create the slave project with the same name you entered during your master project setup and save it in the same directory as the master project. Launch MCC and save the configuration file to the project folder. Under the Project Resources tab, select the master core and click Load Master Settings to import the master configuration file. This enables the slave project to know that the master and slave core configurations are preset in the master project. While importing, a pop-up window may appear with a list of conflicts. In this case, since RB1 has been assigned to both master and slave cores for the clock output function, accepting this message will override the slave project settings. Now, you should see the MSI settings configured in the master project reflected in the slave project. Open the Pin Manager grid view and select RE1 as the GPIO output controlled by the slave core. You may assign a custom name like LED Slave to the pin RE1. Finally, click the Generate button to generate C code for the slave core. This completes our MCC configuration and the generated files should be added to the project. Now that we have created projects for the master and the slave cores, we need to link them together. In the master project, select Slaves in the folder listing and right-click to add the slave project. To verify that the slave project is built every time the master project is built, right-click on Slaves in the folders listing and select Properties to enable Slave Project Build. This completes our dual-core setup. To demonstrate this dual-core setup, we use the code example from our dual-core support page on microchipdeveloper.com. Flash the dsPIC33CH code onto your Explorer 1632 development board and run the project. Code execution is indicated by the LEDs D3 and D4 on the Explorer 1632 board, indicating that the master and slave cores have exchanged the data. Using MCC in your development offers various benefits like generation of non-blocking code that allows easy RTOS integration, significant reduction in configuration time, elimination of manual configuration errors, and facilitates seamless migration. So, take advantage of MPLAB Code Configurator for a quick and hassle-free dual-core dsPIC33CH configuration. Thank you for watching, and for more information, please visit microchip.com/dsPIC33CH.